Okay. Good morning, dear principals, staff members, and dear students. I wish you all a very happy and prosperous new year. Myself, Mrs. Sridevi Polu, Principal TSMS Pudu, is privileged to be a part of this webinar. And today, I would like to invite Mrs. Madhavi, PGT Chemistry from TSMS Pudu, to explain you regarding the second session of 17th group elements children. So in our last session, we have learnt about 17th group elements. What are these 17th group elements and why they are called so? As they contain 7 electrons in their valence shell, they are kept in the 7th group of the periodic table. And according to the IUPAC nomenclature, they are called as 17th group elements. And what are these elements? Fluorine, chlorine, bromine, iodine, and astatine. And astatine is a radioactive element. Okay. And then we have learned about the periodic properties of these halogens. Then why they are called as halogens and about the reactivity. So Madhavi ma'am has explained you in her last session. And today she is going to explain about the most important topics in this chapter children. And at the end of this session, we are going to give you the questions which will appear for your IPE. Okay, so then what is the interesting thing about this session? So that is the interhalogen compounds. What is the meaning of interhalogen compounds? Inter means what? In between. See, the halogens are having a special property, a special nature. What is that? And they combine among themselves to form these interhalogen compounds. And also about the oxo acids. See, you all know about an acid. What is an acid? A proton donor is called as an acid, isn't it? Then what is an oxo acid? If hydrogen is present along with oxygen, we call them as oxo acids. And today we are going to learn about the oxoacids of halogens. So let's welcome Madhavi ma'am. Good morning, ma'am.
Good morning, ma'am. Thank you, ma'am.
Good morning. I wish you a very happy and prosperous new year, ma'am.
Thank you, ma'am. Same to you, ma'am. Thank you so much.
So in this year also, we would like to hear you regarding this webinars. And
Thank you,
see,
ma'am. Thank you so much.
I sincerely appreciate your efforts for making these chemistry webinars a successful one, because you have taught more chapters when compared with other teachers. And I thank you regarding this, Madhavi ma'am.
Thank you, ma'am. It's my pleasure, ma'am. Thank you so much.
Thank you, ma'am. Thank you. Yeah, please continue the session, ma'am.
Yes, ma'am. Yes. Good morning, everyone, and a happy and prosperous new year to one and all. Now, welcome back to today's session 2 on 17 group elements in P block, which is the 6th chapter in your second year. So now let us have a quick review, whatever the subtopics that we have covered in a previous session. So occurrence of 17 group elements we have discussed, and then atomic properties. In atomic properties, electronic configuration. So what is the general electronic configuration of 17 group elements? Ns2, Np5. So they are having 7 electrons in their outer shell. So that's why they belongs to 17th group. Next, atomic and ionic radii we have discussed. In atomic and ionic radii, so you know that these are present at right side of the periodic table. So left to right size decreases. So these are having a small size when compared with the remaining groups in the periodic table. And then ionization enthalpy we have discussed. In ionization enthalpy, which is inversely related to the atomic and ionic radii. So that's why as these elements are having small size, that's why they are having high ionization enthalpy. And after that, electron gain enthalpy. We know, children, it's their general electronic configuration is Ns2 Np5. If they get one electron, they will get the noble gas configuration. Is it not? So Ns2 Np6 is the noble gas configuration, but they are having Ns2 Np5 configuration. If they gain one electron, they will get a noble gas configuration. That's why they readily accept the electron. So because of that, they are having high negative electron gain enthalpy. So out of that, chlorine is having high gain, electron gain enthalpy because of a compact size of fluorine. Fluorine is having very small size. So that's why the attraction towards the electron is less when compared with chlorine. Chlorine is having neither too small size nor too big size. That's why it will attract the electron very easily. Because of that, electron gain enthalpy of chlorine is more when compared with fluorine. That point you have to remember. Next, after that, electronegativity, this is also inversely related to atomic and ionic radii. So you know that these are having a small size. Because of that, they are having high electronegativity. So these are the most electronegative elements in the periodic tables. And fluorine is the highest electronegative element, and it is having 4.0 in Pauling scale. Okay, these after that, we have discussed physical properties, and then chemical properties. In chemical properties, we have discussed oxidation states and trends in chemical reactivity. So -1 is the general oxidation state, and along with the -1, they can also show, except fluorine, they can also show +1, +3, +5, and +7 oxidation states also. Because except fluorine, remaining all other elements of this 17 group are having d orbital. So that's why they can able to show +1, +3, +5, and +7 oxidation states also. And then we have discussed reactivity towards hydrogen. So they form hydrogen halides of a formula HX. And then we have seen reactivity towards oxygen. So they can able to form many oxides. So now today's session. So in today's session, we are going to cover these subtopics. Chemical properties, some more chemical properties. Already we have seen reaction with the hydrogen and reaction with the oxygen. And today we are going to discuss about reactivity towards metals and reactivity of halogens towards other halogens. So it means they can able to form interhalogen compounds, as ma'am said. Okay, so and after that we'll discuss very important for your examination point of view, that is chlorine preparation, properties and uses. Okay, and next, hydrogen chloride HCl. So it's a preparation, properties and uses we'll discuss. And oxo acids of halogens. So already ma'am said what are oxo acids. So we are going to discuss about oxo acids of halogens, and their structure also we'll discuss. Then after that, interhalogen compounds, their preparation, properties and uses. So these subtopics we are going to cover in today's session, children. So now let us start the session with the chemical properties. Few more chemical properties are left. So that is reactivity towards metals. So these halogens, they react with the metals, they form metal halides. What they form? Metal halides. For example, if you consider bromine, when it reacts with magnesium, it forms magnesium bromide. So magnesium plus bromine, Mg plus Br2, is gives rise to MgBr2. So magnesium bromide. Like that, other halogens can also react with the metals. They can form metal halides. Okay, so these metal halides are having ionic nature, because metal form positive charged ion and these halogens form negative charged ion. So there will be electrostatic force of attraction between these two ions. So that's why these metal halides are having ionic in nature. Okay, so this ionic character, it decreases from Mf to Mi. So where M is nothing but it is a metal, monovalent metal. Okay, so for example, Mf is greater than, Mcl is greater than, Mbr is greater than Mi. Okay, so metal fluoride, metal chloride, metal bromide, metal iodide. So metal fluoride is having more ionic character when compared with the metal iodide. Is that clear, children? So one more point you have to remember, that is metal. If a metal exhibits more than one oxidation state, the halides in higher oxidation state will be more covalent than the one in lower oxidation state. So it means if a metal halogen when reacts with metal, if it form more than one metal halide, for example, SnCl4 and SnCl2, if you consider SnCl4, in SnCl4, what is the oxidation state? +4 is the oxidation state. Whereas in case of SnCl2, plus 2 is the oxidation state. So in a SnCl4, it is having plus 4, means more oxidation state. So metal in more oxidation state, it is having a polarizing capacity. So because of that polarizing capacity, why it is having polarizing capacity? Because as the cation charge and cation increases, size will be decreases. So size decreases means nuclear charge will be more towards the outer electrons, so it will get the polarizing capacity. So that's why covalent nature increases. So see children here, SnCl4 and SnCl2, if you compare, SnCl4 will have more covalent nature when compared with SnCl2. If you compare PbCl4 and PbCl2, PbCl4 will have more covalent nature, because in PbCl4 plus 4 is the oxidation state of the metal. So because of a more oxidation state, the polarizing capacity of the metal will increase. So PbCl4 is having more covalent nature when compared with PbCl2. Similarly, SbCl5 is having more polarizing capacity of Sb, because it is in plus 5 oxidation state. So that's why SbCl5 is more covalent when compared with SbCl3. Similarly, UF6 and uranium hexafluoride and uranium tetrafluoride, if you compare these two, UF6 is having more covalent nature. Okay, so only remember what is that metal exhibit more than one oxidation state. The halides in a higher oxidation state will be more covalent than the one in lower oxidation state. Okay children, so that's why SnCl4, PbCl4, SbCl5 and UF6 are more covalent than SnCl2, PbCl2, SbCl3 and UF4 respectively. Okay, so this is about reactivity of halogens with metals. Next one is next chemical property, that is reactivity of halogens towards other halogens. So as ma'am said, so these halogens are having a special property. They can able to react with other halogens. So halogens combine amongst themselves to form a number of compounds known as interhalogen compounds. Okay, interhalogen compounds of the type XX dash and XX dash 3, XX dash 5 and XX dash 7 type of interhalogen compounds they can able to form. What is X and X dash? X is nothing but this is a halogen which is having larger size. And what is X dash? It is also a halogen only, but it is having smaller size. Okay children, okay, so yes, they can able to form interhalogen compounds like XX dash and XX dash 3 and XX dash 5 and XX dash 7 type of interhalogen compounds they can able to form, where X and X dash both are halogens only, but the X is the halogen of larger size and X dash is a halogen of smaller size, right? Okay, next, coming to very important topic, that is chlorine. So till now what we have discussed chemical properties of halogens. Now we'll discuss about chlorine molecule. What is the formula for chlorine molecule? Cl2. In between chlorine and chlorine there is a single bond. Now let us see how to prepare this chlorine. Very important children. So for 8-mark question you will get. So see here, first preparation by heating manganese dioxide. What is the formula of manganese dioxide? MnO2. By heating manganese dioxide with concentrated hydrochloric acid, HCl, MnO2 plus 4HCl is gives rise to MnCl2, manganese dichloride plus chlorine plus H2O. So when manganese dioxide is heated with concentrated hydrochloric acid, then what happens? We'll get chlorine. So this is the first method of preparation of chlorine. Okay, now coming to the second method. So you see children here, in place of hydrogen chloride, concentrated hydrogen chloride, we can able to take salt, common salt, that is sodium chloride and concentrated H2SO4. Sodium chloride and concentrated H2SO4. They give concentrated hydrochloric acid. So in place of HCl, we can able to take common salt and sulfuric acid, concentrated sulfuric acid. They can give hydrochloric acid. So same reaction, write down along with in place of HCl, what we will write? We will write common salt, that is sodium chloride and sulfuric acid along with manganese dioxide. If we heat, then chlorine gas will liberate. Okay, so what are the byproducts? Manganese chloride plus sodium hydrogen sulfide plus H2O plus chlorine. Okay, so again I'm repeating, when sodium chloride plus manganese dioxide plus concentrated sulfuric acid, when they are heated, chlorine gas is liberated. Along with chlorine gas, manganese chloride plus sodium hydrogen sulfide and H2O. So these are the byproducts along with chlorine. So this is the another method for the preparation of chlorine. Next method, by the action of HCl on potassium permanganate. What is the formula of potassium permanganate? KMnO4. So when KMnO4 reacts with hydrochloric acid HCl, it gives chlorine gas, right? Along with chlorine, what are the byproducts? Potassium chloride, manganese chloride and water. Okay, so see the reaction. When potassium permanganate is reacts with the hydrochloric acid, it gives chlorine along with potassium chloride, manganese chloride and water. 2KMnO4 plus 16 HCl is gives rise to 2KCl plus 2MnCl2 plus 8H2O plus 5Cl2. So these are the laboratory methods. Now let's see industrial method for the preparation of chlorine, children. So this is also very important for your examination point of view, manufacture of chlorine. So first method is electrolytic process. So in electrolytic process, chlorine gas can be prepared by the electrolysis of brine solution. What is a brine solution? It is a concentrated sodium chloride solution. So what is brine solution? It is a concentrated sodium chloride solution. When concentrated sodium chloride solution uh, treated electrolysis, then what happens? Chlorine is liberated at anode. Now let us see the process of electrolysis of brine solution. So electrolysis of brine solution can be done in a Nelson cell. So this is the Nelson cell. Let us see the construction of Nelson cell. It is having two electrodes. One is a carbon electrode. It acts as an anode, and steel mesh container, it acts as a cathode. And along with this anode and cathode, it is having porous asbestos lining. Okay, so what happens when this brine solution, when it is kept in this container, when electricity is passed through these electrodes, then what happens? Electrolysis will take place. So after electrolysis, hydrogen gas chlorine gas liberates at anode and hydrogen gas liberates at cathode, and at the bottom of the container sodium hydroxide NaOH is collected. Okay, so these are the byproducts. Now let us see the, after seeing this Nelson cell construction, now let us see the electrode reaction. I think you have understood, children, what it is. Nelson cell is having one anode, that is carbon rod, and one cathode, that is nothing but steel mesh container, and it is having porous asbestos lining, and brine solution is acting like a, brine solution means concentrated sodium chloride solution, acting like a electrolyte. When electricity is passed, then what happens? Chlorine liberates at anode and hydrogen gas liberates at cathode, and at the bottom of the container sodium hydroxide is collected. So now let us see the electrode reactions. No, we know that brine solution we have considered. So brine solution means NaCl in water. So after passing electricity, NaCl dissociate into Na plus and Cl minus, because it is an ionic compound, children. NaCl, it gives rise to Na plus plus Cl minus. Since we are passing electricity, so water, it gives H plus and OH minus ions. Okay, so these positive ions, they move towards the cathode, because cathode is having which charge? Negative charge, and anode is having which charge? Positive charge. So cations moves towards cathode, anions moves towards anode. Okay, so what are the cations here? Na plus and H plus. So they move towards cathode. And what are anodes? Anions here, Cl minus and OH minus. So they move towards anode. So here at cathode we have Na plus and at anode we have OH minus. Na plus and OH minus, they combine, they form sodium hydroxide, caustic soda. Okay, Na plus plus OH minus gives sodium hydroxide. Now what are left at cathode? At cathode H plus ions are left, is it not? So these H plus ions, two H plus ions, they gain two electrons from cathode because cathode is having negative charge. So they gain two electrons from cathode and they convert into hydrogen. So hydrogen H2 molecule. So hydrogen gas liberates at the cathode. Is it clear, children? And at anode, what is left? Chloride ions. These chloride ions, they lose two electrons because anode is having positive charge. So they lose two electrons and they liberate chlorine gas at anode because our concentration is to prepare chlorine gas, is it not? So chlorine, from where we are getting? From anode we are getting chlorine gas. How you are getting chlorine gas? Because sodium chloride, it dissociate into Na plus plus Cl minus. These Cl minus, they move towards anode and they lose two electrons and they convert into chlorine gas, right? Along with this chlorine gas, what are the byproducts that we are getting? Hydrogen gas and sodium hydroxide. Now let us write the overall reaction. NaCl plus H2O is gives rise to what are the products? H2 gas and chlorine gas plus sodium hydroxide. So these are the products. So out of these, chlorine, our concentration is on chlorine because chlorine it obtained at anode. So we are discussing about the methods of preparation of chlorine from brine solution. So this is the electrolytic method, children. Next one, very important, and next one is also very important, that is Deacon's process for the preparation of chlorine. So by oxidation of hydrogen chloride gas by atmospheric oxygen in the presence of a copper chloride, copper chloride acts as a catalyst at 723 Kelvin. So we'll get the chlorine gas. Okay, what is that? By oxidation of hydrogen chloride gas on oxidation in presence of atmospheric oxygen and the catalyst. What is the catalyst here? Copper chloride, CuCl2. What is the temperature? 723 Kelvin. So at this temperature and in the presence of copper chloride, hydrogen chloride undergoes oxidation in presence of atmospheric oxygen and gives chlorine gas plus water. So you can see in this figure. So these are the this is the container. So these are the two inlets. So through this inlet, hydrogen gas is HCl gas is passed, hydrogen chloride gas is passed, and through this inlet, oxygen gas is passed from the atmosphere. And this is the catalyst, so it means copper chloride. So in the presence of this copper chloride, and this container is maintained at 723 Kelvin. So at this temperature and in this presence of this copper chloride catalyst, so hydrogen chloride gas, it undergo oxidation and it gives chlorine gas. So this chlorine gas can be obtained from this outlet. Okay, so these two are the inlets. So through these inlets, hydrogen chloride gas and oxygen are passed, and inside the container catalyst is present, that is copper chloride is present, and this container is at 723 Kelvin. So hydrogen chloride gas, it undergo oxidation and forms chlorine. So is it an oxidation? Because chlorine here, what is the oxidation state of chlorine here? -1. Whereas in Cl2, what is the oxidation state of chlorine? 0. -1 to 0. Increase in oxidation number. So increase in oxidation number shows that it is a oxidation reaction. So hydrogen chloride undergone oxidation in presence of atmospheric oxygen and gives chlorine gas. So this is the Deacon's process. Very important, children. Whenever you will get a name, so that means that examination point of view, that is very important. So just you practice this reaction. What is that? HCl4 HCl plus O2 is gives rise to CuCl2 arrow in an arrow because it is a catalyst. It gives 2Cl2 plus 2H2O, right? So this is about the preparation of chlorine. Now coming to the properties of chlorine. So it is a greenish yellow gas with a pungent and suffocating odor. It is about 2 to 5 times heavier than air. It can be liquefied easily into greenish yellow liquid which boils at 239 Kelvin. It is soluble in water. Okay, so these are the physical properties. It is a greenish yellow gas with a pungent and suffocating odor and 2 to 5 times heavier than air, and it can be easily liquefied into greenish yellow liquid, and it boils at 239 Kelvin, and it is soluble in water. Now let us see the chemical properties of chlorine, children. Chlorine reacts with a number of metals and non-metals to form chlorides. Okay, so when chlorine reacts with aluminum gives aluminum chloride. Very simple reactions. When chlorine reacts with iron gives iron chloride. When chlorine reacts with sodium gives sodium chloride. When chlorine reacts with sulfur gives sulfur chloride. When chlorine reacts with phosphorus gives phosphorus chloride. Okay, 2Al plus 3Cl2 is gives us to 2AlCl3. 2Fe plus 3Cl2 is gives us to 2FeCl3, ferric chloride, aluminum trichloride. Okay, sodium plus Cl2, 2Na plus Cl2 is gives us to 2NaCl, sodium chloride. S8 means sulfur plus chlorine, 4Cl2 is gives us to 4S2Cl2. And P4 phosphorus plus 6 chlorine molecules, they combine to give 4PCl3, phosphorus trichloride. So the chlorine can able to react with a number of metals and non-metals, and it can able to form chlorides. Okay, next one is it has great affinity for hydrogen, so it reacts with the compounds containing hydrogen to form HCl. Okay, so it great affinity means it highly reacts with compounds which are having hydrogen. So, and it gives HCl. For example, if you consider when chlorine reacts with hydrogen, it gives a HCl, 2HCl, and when it reacts with the hydrogen sulfide, H2S, chlorine, when reacts with the hydrogen sulfide, it gives HCl plus sulfur. And when it reacts with C10H16 hydrocarbon, and it gives HCl plus carbon. Okay, and when chlorine reacts with water, it gives HCl plus oxygen. So like that, chlorine is having high affinity towards the compounds which are having hydrogen like H2, H2S, and C10H16 means hydrocarbons, and water. All these are having hydrogen. So that's why chlorine, it can able to react these compounds, and it can give HCl. Okay, next one. With cold and dilute alkalis, chlorine produces a mixture of chloride and hypochlorite. But with hot and concentrated alkalis, it gives chloride and chlorate. Very, very important for your examination point of view, these reactions, children, because chlorine, it is not giving same type of products with cold and dilute alkalis and hot and concentrated alkalis. So it is giving different products. So that's why this is very important for your examination point of view. First, let us see when chlorine reacts with cold and dilute alkali, means we are considering here sodium hydroxide, cold and dilute sodium hydroxide. When chlorine reacts with cold and dilute sodium hydroxide, it gives sodium chloride plus sodium hypochlorite, NaOCl, sodium hypochlorite. NaOCl is called as sodium hypochlorite plus H2O. Okay. Next, now coming to chlorine, when it reacts with hot and concentrated alkali. So we'll consider sodium hydroxide, hot and concentrated sodium hydroxide. So when it reacts with chlorine, it gives NaCl plus H2O as above reaction. But what is the different product that we'll get? That is sodium chlorate, NaClO3. NaClO3 is called sodium chlorate, and NaOCl is called as sodium hypochlorite. So these are the two differences. Okay, so NaCl, NaCl, H2O, H2O is same everything, but here only this one and this one is different. Here sodium hypochlorite will get when cold and dilute alkali is considered, and when hot and concentrated alkali considered, then when we'll get sodium chlorate. So that is the difference, children. So it is very easy if you practice that. So, and after that, this chlorine, when it reacts with dry slackle lime. So what is dry slackle lime? CaOH twice, that is solid CaOH twice. Suppose if it is a liquid, then it is called as lime water, but it is a solid CaOH twice. Dry slackle lime, it gives bleaching powder. When chlorine reacts with dry slackle lime, it gives bleaching powder, CaOCl twice plus CaCl2 plus 2H2O. So this is the composition of bleaching powder. So what is that? When chlorine reacts with dry slackle lime, what we will get? We will get bleaching powder. What is the formula of bleaching powder? CaOCl twice plus CaCl2 plus H2O. So this is the composition. Okay. So calcium oxychloride. Okay. So and calcium chloride plus water. So these are the products that we'll get when the chlorine reacts with dry slaked lime. Okay, so very important for examination point of view, children. Next, with excess of ammonia, chlorine gives nitrogen and ammonium chloride, whereas with excess chlorine, nitrogen trichloride is formed. See here, children, difference. If we consider ammonia as excess, then we'll get ammonium chloride and nitrogen gas. If we consider excess of chlorine, we'll get nitrogen trichloride, which is explosive, okay, highly explosive one, nitrogen trichloride plus HCl. Okay, so here the reactants are same, but the composition is different, because ammonia, in the first reaction we are considering ammonia excess, excess we are considering, so that's why we'll get ammonium chloride plus nitrogen, whereas 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 in case of ammonia, if you consider chlorine as excess, then what happens? Nitrogen trichloride plus nitrogen trichloride plus uh, HCl will get. Okay, right, children? So next. Next one, chlorine reacts with hydrocarbons and gives substitution products with saturated hydrocarbons and addition products with unsaturated hydrocarbons. So this is also important, children. What is that? When chlorine can able to react with saturated hydrocarbons as well as unsaturated hydrocarbons. What are saturated hydrocarbons? All single bonds. So hydrocarbons which are having single bonds and the carbon undergoes sp3 hybridization, those hydrocarbons are called as saturated hydrocarbons. What are unsaturated hydrocarbons? The compound, the hydrocarbons which are having double bonds and triple bonds, alkenes and alkynes, are called as unsaturated hydrocarbons. So we know that saturated hydrocarbons undergo substitution reactions and unsaturated hydrocarbons undergo addition reactions. Is it not? So when chlorine reacts with saturated hydrocarbons, for example methane if we consider, then what happens? Substitution reaction will take place and the substituted product methyl chloride. So in place of hydrogen, one chlorine is substituted, that is CH3Cl plus HCl. So this is a substitution reaction because it is a saturated hydrocarbon. If we consider unsaturated hydrocarbon like ethene, in ethene, in between carbon and carbon there is a double bond. So then what happens? Addition reaction will take place. So chlorine get add at a double bond, one double bond will break and chlorine get add at both carbons and we'll get 1,2 dichloroethane. C2H4Cl2 is called as 1,2 dichloroethane. Very simple, children. Chlorine when reacts with saturated hydrocarbons will get a substitution product, and if it reacts with unsaturated hydrocarbons will get the addition product. Okay, next coming to chlorine water on standing loses its yellow color due to the formation of HCl and HOCl. We know that chlorine is having yellow in color, so chlorine water. But on standing means if you keep it for some time, then what happens? Chlorine water, it loses its yellow color because of the formation of HCl and HOCl. So hypochlorous acid, HCl is hydrochloric acid, and HOCl is hypochlorous acid. But this hypochlorous acid, HOCl, is unstable. It will convert into HCl by giving one nascent oxygen. Oxygen atom is called as nascent oxygen. So this nascent oxygen is responsible for the oxidizing and bleaching properties of chlorine. Chlorine is having bleaching property and oxidizing property. Why this chlorine is having chlorine water is having a bleaching property or oxidizing property? Because of this nascent oxygen, hypochlorous acid, which is formed on standing of chlorine water. It is unstable, it decomposes to give HCl and nascent oxygen. That nascent oxygen is responsible for the bleaching action of chlorine and oxidizing action of chlorine. Okay, now let us see oxidizing character of chlorine. Just now only we have discussed chlorine is having oxidizing character. It oxidizes ferrous to ferric and sulfide to sulfate. See children here, ferrous sulfate. In ferrous sulfate, what is the oxidation state of iron? Plus 2 is the oxidation state, ferrous sulfate. So when it combines with chlorine in presence of a sulfuric acid, it gives a ferric sulfate. In ferric sulfate, what is the oxidation state of iron? Plus 3. So plus 2 to plus 3, increase in oxidation number. It means that oxidation has been taken place. Because chlorine is a oxidizing agent. Is that clear children? What is that? Ferrous sulfate, chlorine can able to convert oxidize ferrous sulfate to ferric sulfate in presence of sulfuric acid. In ferrous, iron is having plus 2 oxidation state. In ferric sulfate, iron is having plus 3. So increase in oxidations number. So it shows that oxidation has been taken place. Okay. Similarly, chlorine can able to oxidize sulfide to sulfate. So sodium sulfide. So in sodium sulfate, what is the oxidation state? Plus 4 is the oxidation state. So in sodium sulfate, what is the oxidation state of a sulfur? Plus 6 is the sulfur oxidation state. Plus 4 to plus 6. So it means increase in oxidation number. So increase in oxidation number shows that oxidation, chlorine, it oxidizes sodium sulfide to sodium sulfate. Is it clear children? Okay. So in presence of water, so chlorine, it reacts with sodium sulfide, it gives sodium sulfate. So increase in oxidation number, it shows that oxidation has been taken place. Chlorine is a oxidizing agent. Okay. Next, chlorine reacts with hypo to form Na2SO4. What is hypo? Na2S2O3 is called as a hypo. Okay. So chlorine, it reacts with hypo and it gives Na2SO4, sodium sulfate. Okay. So what is the oxidation state here? Plus 1 is the oxidation state for here, plus 6. So increase in oxidation number, it shows that oxidation has been taken place. So chlorine, this is also examination point of view, very important children, how chlorine reacts with the hypo. So chlorine reacts with hypo to form sodium sulfate. Oxidation takes place along with the sodium sulfate. HCl and sulfur will also form. Okay. So these are the reactions. Next, some more. Chlorine oxidizes sulfur dioxide to sulfur trioxide, means SO2 to SO3, and iodine to iodate. But this sulfur trioxide and iodate, so in presence of water, they convert into sulfuric acid and iodic acid. What is the formula of iodic acid? HiO3. Okay. So chlorine, when reacts with the sulfur dioxide, sulfur, it converts into sulfur trioxide. But in presence of water, what we will get? Sulfuric acid, H2SO4 plus HCl. And iodine, it converts into, in presence of chlorine, it oxidizes to iodate ion, but in presence of water, we'll get iodic acid, HiO3, right, plus HCl. SO2 plus H2O plus Cl2 is gives rise to H2SO4 plus HCl. 2 HCl, and yeah, I2 plus 6 H2O plus 5 Cl2 is gives rise to 2 HiO3 plus 10 HCl. So sulfur dioxide to sulfuric acid in presence of water, chlorine, it converts sulfur dioxide to sulfuric acid, and chlorine in presence of water, it converts iodine to iodic acid. HiO3 is iodic acid and H2SO4 is sulfuric acid. Okay. Next one is chlorine is a powerful bleaching agent. Bleaching action is due to oxidation. Just now only we have discussed, children, chlorine water. It gives HCl and HOCl. But HOCl, hypochlorous acid, is unstable. It decomposes to give nascent oxygen, right? So that nascent oxygen is responsible for the bleaching action of chlorine, and it is having oxidation property, right? So it bleaches vegetables or organic matter in presence of moisture. Bleaching effect of chlorine is permanent. Okay. Cl2 plus H2O is gives rise to 2 HCl plus this nascent oxygen. Okay. Hypochlorous acid is formed. That hypochlorous acid again will get nascent oxygen. This nascent oxygen, that is atomic oxygen, is responsible for the bleaching action and oxidizing property of chlorine. So colored substances, when they combine with this nascent oxygen, they convert into colorless substances. So that is called as bleaching action, right, children? Okay. Next one is uses of chlorine for bleaching wood pulp. So required for the manufacture of paper and rayon. So wood pulp, in a wood pulp industry, so chlorine is used as a bleaching agent because it converts colored substances into colorless substances because of nascent oxygen. And in a bleaching cotton and textile industry, so it converts colored substances into colorless substances. Okay. In the extraction of gold and platinum also, this chlorine is used. In the manufacture of dyes, drugs, and organic compounds such as the carbon tetrachloride and chloroform, DDT, refrigerants, all these things for the preparation, this chlorine gas is used. So these are the uses of chlorine again. So for bleaching wood pulp, required for the manufacture of paper and rayon industry, bleaching cotton and textiles, and in the extraction of gold and platinum, chlorine gas is used. In the manufacture of dyes, drugs, and organic compounds such as carbon tetrachloride and chloroform, DDT, refrigerants. So all these organic substances can be prepared by using chlorine. Okay, so this is about chlorine preparation and properties, chemical properties and uses. Okay, children. Next, in sterilizing drinking water, because it is having a oxidizing character, it oxidizes microorganisms. So for that purpose, sterilizing drinking water, chlorine gas is used. Preparation of poisonous gases such as phosgene, COCl2 is called as phosgene, and tear gas, that is CCl3NO2, and mustard gas, ClCH2CH2S CH2CH2Cl, this is called mustard gas. All these three are poisonous gases. So by using chlorine, these poisonous gases can also be prepared. Okay, in sterilizing drinking water and in preparation of poisonous gases, phosgene, tear gas, and mustard gas, this chlorine is used. Okay, so these are the uses. Now coming to the another subtopic, that is hydrogen chloride, HCl. So how this HCl is prepared? So in laboratory, let us see. It is prepared by heating sodium chloride with concentrated sulfuric acid. Children, in the preparation of chlorine also we have discussed, when sodium chloride in place of HCl, we can able to take common salt and sulfuric acid, is it not? So sodium chloride plus sulfuric acid gives HCl, hydrogen chloride. Along with HCl, sodium hydrogen sulfate is formed. So by considering sodium hydrogen sulfate, again HCl can be prepared. So when it is treated with sodium chloride, sodium hydrogen sulfate plus NaCl, when it is heated at 823 Kelvin, we will get a hydrogen chloride along with Na2SO4. Okay. So this obtained HCl, it can be dried by passing through concentrated sulfuric acid. Whatever the HCl that we got in these two reactions, that can be dried by passing the concentrated sulfuric acid, because concentrated sulfuric acid is a dehydrating agent. It absorbs the moisture from HCl. Okay, so like that, the hydrogen chloride can be prepared. Now let us see the properties of hydrogen chloride, children. It is a colorless and pungent smelling gas. It is easily liquefied to colorless liquid, which is having boiling point 189 Kelvin, and freezes to white crystalline solid of freezing point 159 Kelvin. Okay, so it is easily liquefied to colorless liquid. Boiling point is 189 Kelvin, and it can be converted into solid, which is white crystalline solid, and freezing point is 159 Kelvin. So we know that this hydrogen chloride highly soluble in water, and it ionizes. See here, HCl plus H2O is gives rise to H3O plus Cl minus. So we know, children, hydrogen chloride gas is not a acid, because it will not give H plus ions. Okay, the substance which gives H plus ions is called as acid, but dry HCl, dry hydrogen chloride gas, is not a acid. It will not convert blue litmus to red. Okay, but moist blue litmus can be converted into red, because HCl, in presence of moisture, it acts as a acid, because it gives H plus ions. By seeing this equation, you can easily say HCl, when it is dissolved in water, it dissociates to give H3O plus Cl minus. Very important point you have to remember. HCl gas is not a acid, but HCl in water is an acid, because it is giving H plus ions. Okay, what is the dissociation constant? Ka is equal to 10 to the power of 7. Very high dissociation constant. So that's why HCl, it easily dissociate in presence of water, and it gives H3O plus Cl minus. So in aqueous solution is called as hydrochloric acid. Dry HCl is called as hydrogen chloride gas, whereas HCl in water is called as hydrochloric acid, because it is providing H plus ions. Okay, and we have seen, children, 10 to the power of 7 is the dissociation constant. So what is the Ka? Ka is equal to 10 to the power of 7. It indicates that HCl is a strong acid in water. Next, it reacts with ammonia. It gives white fumes of NH4Cl. So when ammonia gas, so in qualitative analysis, this experiment we will use, okay, for the detection of ammonia gas. Ammonia, when reacts with HCl, it gives white fumes of ammonium chloride. Okay, so next, when 3 parts of concentrated HCl and 1 part of concentrated HNO3 are mixed, Aqua Regia is formed, which is used for dissolving noble metals. So very important, children, what is Aqua Regia? 3 parts of HCl and 1 part of concentrated HNO3. So this is called as Aqua Regia. So what is the speciality of this Aqua Regia? So in this Aqua Regia, it can able to dissolve noble metals. We know that gold, platinum are noble metals. They will not react with any other substances. But these noble metals can also be dissolved in Aqua Regia. What is the Aqua Regia? 3 parts of HCl and 1 part of concentrated HNO3. Right? So what is the reaction? Gold, when it reacts with H plus NO3 minus plus Cl minus, it gives rise to AuCl4 minus plus nitric oxide plus H2O. So because of the formation of this product, gold, it dissolves in nitric acid, 1 part of nitric acid and 3 parts of HCl, that is called as Aqua Regia. Similarly, platinum can also react with Aqua Regia. So 3Pt plus 16H plus 4NO3 minus plus 18Cl minus. So H plus ions are obtaining from HCl and HNO3, and NO3 minus ions are obtaining from nitric acid, and Cl minus ions are obtaining from HCl. So when these ions combines with platinum, that is noble metal, we'll get PtCl6 2 minus. So because of the formation of this product, platinum is combining with Aqua Regia, and along with the nitric oxide and H2O also formed. Okay, so what is Aqua Regia, children? 3 parts of concentrated HCl and 1 part of nitric acid. What is the speciality of Aqua Regia? So in Aqua Regia, noble metals, gold and platinum. Why they are called as noble metals, children? Because they are inert. They will not react with substances, most of the substances, but they can able to react with Aqua Regia. That is 3 parts of HCl and 1 part of concentrated HNO3 is called as Aqua Regia. Okay. Next one is hydrochloric acid decomposes salts of weaker acids. For example, what are salts of weaker acids? Carbonates, hydrogen carbonates, and sulfides. You can see here sodium carbonate and sodium hydrogen carbonate and sodium sulfite. So when a hydrochloric acid reacts with sodium carbonate, it decomposes to give sodium chloride plus H2O plus carbon dioxide, and hydrogen chloride, when reacts with sodium hydrogen carbonate, it gives NaCl plus H2O plus CO2, and similarly HCl, it reacts with sodium sulfite, gives sodium chloride plus H2O plus SO2. So this hydrochloric acid, it decomposes salts of weaker acids like carbonates, hydrogen carbonates and sulfites to give sodium chloride and water. Along with that, the carbon dioxide, when they are carbonates, then carbon dioxide. When it is sulfite, it gives sulfur dioxide. Very simple reactions, children, just practice is required. Okay, now coming to uses. Till now what we have discussed: preparation of hydrogen chloride and preparation of chemical properties of hydrogen chloride. Now coming to the uses of hydrogen chloride in the manufacture of chlorine and ammonium chloride and glucose from starch. Okay, corn starch. Next, for extracting glue from bones and purifying bone black, and in medicine and as a laboratory reagent, this hydrogen chloride is used. Okay, so in the manufacture of chlorine and ammonium chloride and glucose. Next, for the extracting glucose from bones and purifying bone black, and in medicine and as a laboratory reagent, this hydrogen chloride is used. Now coming to the oxoacids of halogens, children. What means acid? You know what is the substance which gives H plus ion is called as acid. But what is oxoacid? So along with the H plus, if oxygen is also present, then those acids are called as oxoacids of halogens. So these halogens, they can able to form many oxoacids. For example, hypochlorous acids, hypohalous acids, halic acids, and perhalic acids. So now let us see fluorine. It can able to form only hypofluorous acid, that is HOF. Okay, and next chlorine, if you consider chlorine, it can able to form hypochlorous acid, chlorous acid, chloric acid, perchloric acid. What is the formula of hypochlorous acid? HOCl. Chlorous acid, HOClO. Means you can write like this, HClO2. Okay, next chloric acid, HOClO2, and perchloric acid, HOClO3. Okay, very easy to remember, children. Hypochlorous acid, HOCl, chlorous acid, HOClO, one oxygen extra, and chloric acid, HOClO2, one oxygen extra, and perchloric acid, HOClO3. So chlorine can able to form all 4 type of oxo acids. But now coming to bromine. So bromine, it can able to form only 3 types of oxo acids: hypobromous acid, HOBr, bromic acid, HOBrO2, and perbromic acid, that is HOBrO3. It cannot form bromous acid. Okay. Similarly, iodine also can able to form 3 types of oxo acids: hypoiodous acid, and it cannot form iodous acid, and it can form iodic acid, that is HOiO2, and it can able to form periodic acid, that is HOiO3. Now let us see the structure of these oxo acids, children. For example, we'll consider chlorine oxo acids. So hypochlorous acid, that is HOCl. In HOCl, chlorine is attached with one OH group. So what is the oxidation state of chlorine here? +1 is the oxidation state in hypochlorous acid. So next one is chlorous acid. In chlorous acid, it is having extra oxygen, is it not? Chlorine along with this OH, it is forming one single bond and double bond with one oxygen. In that case, chlorine is having +3 oxidation state. Next one is chloric acid. In chloric acid, one oxygen is extra, is it not? So chlorine, it can able to form single bond with OH and two double bonds with two oxygens, and the oxidation state of chlorine in chloric acid is +5. And next one is perchloric acid, one oxygen extra with the chloric acid. So chlorine, it is forming a single bond with OH and three double bonds with three oxygens. Okay, so children, this OH is responsible for the proton donation. That means it gives H plus ion by the breaking of this bond. Okay, so like that, these oxo acids acts like a acids. So this is about the structure, oxidation states of oxo acids of chlorine. Next one is last topic, that is interhalogen compounds. So children, halogens are having a special property. They can able to react with other halogens. Okay, so they can able to form interhalogen compounds. When two different halogens react with each other, interhalogen compounds are formed. As already we have discussed which type of interhalogen compounds we can able to get: XX dash, XX dash 3, XX dash 5 and XX dash 7 type of interhalogen compounds we can able to get. So what is X and X dash? Both X and X dash are halogens only, but what is the difference? X is the halogen of larger size and X dash is the halogen of smaller size. X is more electropositive than X dash because the size of X is more. So that's why that is more electropositive when compared with X dash, because X dash is having smaller size. Okay, now let us see how to prepare these interhalogen compounds. So children, if we consider two halogens in equimolar, then what we'll get? We'll get for example, chlorine plus F2, 1:1 ratio if you consider, then we'll get ClF. Similarly, I2 plus Cl2 equimolar, we'll get ICl. Okay, so X dash type of halides, when we'll get, if you consider two halogens in equimolar, 1:1 ratio if you consider, then we'll get X dash type of interhalogen compounds. Next one, if you consider 1:3 ratio of these halogens, for example, chlorine Cl2 plus 3F2 here. So chlorine is 1 and fluorine is 3. 1:3 ratio we have considered, means fluorine we have considered, X's we have considered. So in that case, X dash 3 type of interhalogen compounds will get. So ClF3. Similarly, Br2 plus 3F2. So 1:3 ratio. That's why X dash 3 type of interhalogen compound, that is BrF3 type of interhalogen compound we got. Okay. Similarly here Br2 5F2. So 1:5 ratio, that is excess of fluorine. So then we'll get a BrF5. Okay. If you consider 1:7 ratio of these halogens, then what happens? We'll get IX-7 type of interhalogen compounds will get. So it's very simple, children. Just it depends upon the ratio of halogens that we are taking. So that depends on the ratio. We can able to easily prepare these interhalogen compounds. Okay. Next, coming to the some properties of interhalogen compounds. So see children, ClF, XX dash type of interhalogen compound, ClF, BrF, IF and BrCl, ICl. So these first one is colorless gas and BrF is pale brown gas and IF is detected spectroscopically and BrCl is a gas and ICl So ruby red solid, alpha form if you consider, but beta form is having brown red solid. Okay, and IBr is black solid. Next, coming to XX-3 type, so ClF3, BrF3, IF3, ICl3. So this is the first one. ClF3 is a colorless gas. So see children, XX-3 type of interhalogen compounds are having a bent shape. Very, very important. What they are having? XX-3 shape are having bent T-shaped structure they are having. We'll see now. Okay, so BRF3 is yellow green liquid and IF3 is yellow powder and ICl3 is orange solid. All these XX-3 type are having T shape. Now coming to XX-5. So IF5, BRF5 and ClF5. So IF5 is a colorless gas but solid below 77 Kelvin, and BrF5 is colorless liquid and ClF5 is colorless liquid. So all XX-5 type of interhalogen compounds are having square pyramidal structure. Okay. Next, XX-7 type is the example IF7. It is a colorless gas. It is having a pentagonal bipyramidal structure. See children, here we can see. So XX-3 type are having T-shaped structure. They are having two lone pair of electrons. ClF3 is an example. They are having two lone pairs. So because of these two lone pairs, they are having T-shaped structure. Whereas in a XX-5 type, BrF5, if you consider, BrF5 is having square pyramidal structure and it is having one lone pair of electron. Next one is IF7, that is XX-7 type of interhalogen compound. Example IF7, it is having pentagonal bipyramidal structure because here 5 fluorines are there and these are axial bonds, the 2 fluorines. So this is having pentagonal bipyramidal structure. Okay. Next, uses of last one, uses of interhalogen compounds. So these compounds can be used as a non-aqueous solvents. Interhalogen compounds are very useful fluorinating agents, and ClF3, BrF3 are used for the production of uranium hexafluoride in enrichment of uranium. Okay, so uranium, when it reacts with the ClF3, it gives uranium hexafluoride along with the ClF. Okay, children. So this is about uses of interhalogen compounds. These compounds are used as non-aqueous solvents, and interhalogen compounds are very useful fluorinating agents. And ClF3, BrF3 are used for the production of uranium hexafluoride from uranium. So when reacts with uranium, when reacts with the chlorine tetrafluoride, trifluoride, ClF3 trifluoride, it gives uranium hexafluoride plus ClF. Okay, so these are the uses of interhalogen compounds, children. I hope you have understood. Now these are the some important questions. So how chlorine is prepared in laboratory, how chlorine is prepared in Deacon's process, very important. How does it react with the following: cold and dilute sodium hydroxide and hot sodium hydroxide, hot and concentrated sodium hydroxide, and excess of ammonia if we consider with the slaked lime, how it is reacted, and hypo with the hypo sodium sulfate is obtained, is it not? So today only we have discussed. And how is chlorine prepared by electrolytic method, Nelson cell we have seen, children. Explain its reactions with iron and esterified ferrous sulfate and iodine and hydrogen sulfide and potassium iodide. So next one is write the reactions of fluorine and chlorine with water. So these are very important questions from this group, children, 17 group. So these are the frequently asked questions. Just go through these. Just now only we have discussed all these questions. Now what we have learned, so in chemical properties we have discussed reactivity towards metals and reactivity of halogens towards halogens called as interhalogen compounds, and chlorine preparation properties and uses we have discussed today, and hydrogen chloride preparation properties and uses, and oxoacids of halogens, their structure also we have seen, and interhalogen compounds preparation properties and their structure we have discussed, and their uses also we have discussed. So these are the subtopics that we have discussed in 17 group elements, children. So if you go through these important questions, definitely you will get good marks. Thank you so much for this opportunity. Hope you have understood well. Thank you, ma'am.
Thank you, Madhavi ma'am.
Thank
Thank you for
you.
the wonderful session. You have very clearly explained this topic. Moreover, you have explained every topic very clearly, ma'am. It's our privilege to have you in the chemistry webinar team, ma'am.
Thank you,
Really,
ma'am. Thank you.
really, we are very thankful to you because you have taken a lot of pain to prepare these PPTs because it's not so easy to prepare a PPT, right? And every teacher who is teaching this webinars, they know that pain. And really, I'm very thankful to you, ma'am, Madhavi ma'am.
Thank you so much, ma'am. It's
Then,
wonderful, ma'am.
dear children, here I want to mention you one thing. See, at the end of the session, ma'am has given you some questions which will appear in your IPE from this chapter, isn't it? See how chlorine is prepared by Deacon's process and how does it react with certain compounds like dilute and cold NaOH, hot and concentrated NaOH, okay, and then excess of ammonia. How does it react with excess of ammonia and when it how does chlorine reacts with the excess of ammonia and also when ammonia is less and chlorine is more. These two reactions are very, very important, children. So please learn these reactions. And already I told you that you will get two sub questions from these inorganic chemistry topics. Like from 5A group elements, sometimes you may be asked one 4 marks question, and the other 4 marks question may be asked from 16th group elements. Like that, don't expect a single 8 marks question from the same chapter. So it shows that you had to be thorough with all the groups. That means the 15th group, 16th group, and 17th group. And here I have to mention you one thing regarding the oxoacids of halogens. See, the oxoacids of chlorine are very important. Hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. And you should remember that perchloric acid is the strongest acid among all the mineral acids. Okay. So what are mineral acids? HCl, HNO3, H2SO4. These are all the mineral acids, isn't it? Organic acids are different. So mineral acids are stronger than the carboxylic acids. And then the perchloric acid is the most strongest one among all the acids. Okay. And then ma'am has very clearly explained you regarding the interhalogen compounds, their structure, and then hybridization. So please learn this, and it is also the frequently asked question for 4 marks. Okay. So I thank Shailaja ma'am for providing this platform to reach you children, and she is also putting all her sincere efforts to make this webinars wonderful one. So thank you, Shailaja ma'am. And once again, I'm very thankful to Madhavi ma'am
Shall
for
thank you.
her coordination and support extended for teaching so many lessons to you children. So I hope each and everyone is watching this session and writing down the notes and learning the topic. So thank you everyone.
Thank
Thank
you.
you ma'am.